Hey scientists, it's Mrs. Aquilia, and I'm coming at you from my kitchen science lab for science experiment of the week, number 13, and it's called Floating Eyeball. Before we begin with the floating eyeball, I want to just remind you of what we've been discussing in some of our experiments. We learned that different liquids have what's called different density, that they are all made of something called molecules, these little itty bitty things that we can't see. And the more dense a liquid is, the more molecules it has and the closer together they are. So we can see from this picture that water is more dense than oil. Water has more molecules and you can see that they're closer together. The oil has a lot less molecules than the water and they're much further spread apart. So we're going to take that information and we are going to take a whole bunch of liquids and we're going to put them all together and see what happens. We have oil, we have corn syrup, we have dishwashing liquid, regular like dish soap that you'd wash dishes with. We have, this is just water and it has a little green food coloring. And we're also using something called rubbing alcohol, and that's just something that you may have at home. It's mostly used for cleaning, and because it's clear, I put in some food coloring so we can see that as well. Now, I went ahead and I did this before I started the video because I hold my camera with one hand and I needed two hands for this process. And look at what happened. I took all of these different liquids of different densities, I put them all together, and they all settled in these different layers, right? Kind of just like in my picture, only now there's 5 of them. 1, 2, 3, 4, 5. Yes, 5. The very bottom, the most dense, is the corn syrup. On top of that, we have the dishwashing liquid. On top of that, we have the water. On top of that, we have the oil. And on top of that, making kind of a really interesting shape, we have the rubbing alcohol. How cool is that? That's really neat, right? But wait, there's more! Because what we're going to be doing with this is we are now going to take some objects and we're going to be plunking the objects in this container and we're going to see what these objects do. Now, I want to remind you of something we learned in the last experiment called buoyancy. We were looking at the buoyancy, which means whether something is able to float, by putting objects in water. And what we learned is that buoyancy does not have to do with how heavy an object is. It has to do with how dense an object is, as well as how much space it takes up. But we're focusing mostly on the density. So this means that it's not just liquids that have density, it's also the objects that we put in the liquids, right? So if we put different objects of different densities in different liquids of different densities, what's gonna happen? Well, you're gonna find out right now. And boys and girls, I hope that you don't hear all this noise. They're doing some construction in my apartment building, which they seem to do a lot of. Okay, so let me just get this ready. Okay, so we have 4 different objects. We have a bean, and this is just a regular bean that we would eat. We would cook it in whatever way, and we would eat it. This is a little cotton ball, sort of. It's the end of a Q-tip. You guys know what a Q-tip is, right? I just cut off the end of that. Then we have this little piece of tinfoil, and then we have a little ball of clay. Okay, so I want you to make a prediction. We're going to first take this bean, and I want you to predict what you think is going to happen when I plunk it in there. So put me on pause, make a prediction, and then come back to me. All right, here we go. Boys and girls, look at that. Do you see where that landed? It landed at the top of the layer of corn syrup. So it's not floating. It went all the way through these layers and then stopped here. Why do you think that is? Well, the reason why is because the bean is more dense than the alcohol, the oil, the water, the soap, but it's not more dense than the corn syrup. It's less dense, so it came to stop at the top of that layer, and it looks like it's just kind of floating. Well, it is, really. It's floating on top of the corn syrup. How cool is that? Okay, now we're going to take our little clay ball. It's a lot smaller than the bean, right? I want you to make a prediction now. Now that you see that it's possible to go through some layers and not others, I want you to make a prediction. What do you think is going to happen when we take this little clay ball and we drop it in? Bloop. Look at what's happening. It's moving a little slow because that corn syrup is really thick and dense. But look what happened. Even though the clay ball is a lot smaller than that bean, it went all the way to the bottom. It sank through every single layer. You see that? So that is telling us that that clay ball, even though it's small, it's denser. It has more density than every single liquid in there and more density than the bean. So we have the clay ball on the bottom, and then we have the bean resting on top of that corn syrup layer. Oh my God, this is so cool. Okay, so we are now going to take our little piece of cotton. I'm going to see what happens. Bloop. Whoops, I made my bloop sound too soon. There we go, bloop. That's really cool. It's staying at the bottom of that layer of alcohol, but it's like stretching the layer down. What is that about? Is it going to fall or is it going to stay? Well, for right now, we're going to leave it alone. I'm just going to see what happens. And now we come to the little bowl of tin foil, and we're going to see what happens when we put this in. Okay, so I accidentally dropped the tin foil in. I was holding it above the thing and I accidentally let go. So look at that. We have the tin foil at the top of the water layer. So the tin foil is more dense than the alcohol and the oil. The Q-tip, I don't know what's happening with that Q-tip. I want to fish out that Q-tip and see what happens if we drop it in again on the other side. All right, I actually fished that one out. Sometimes what I find is that if you do the objects too close to each other, you can't tell if one is like on top of the other, if it's trying to get through the layer or if it's just sitting on top of the object. So I have another cotton ball. I'm going to drop it on the other side so it's not near the tin foil and see what happens. It's funny, I dropped it on the other side and it actually went right to the middle. And it's still holding tough at the bottom of that alcohol layer. So we have 1, 2, 3, 4. We have our 5 liquids, and now we have 4 objects. Are you still wondering why I call this floating eyeball? We do have one more object. This, boys and girls, is why we call it floating eyeball. So that eyeball is the least dense of all. That eyeball is not more dense than any of those liquids. It is less dense than everything. It's less dense than every liquid and every object. And that little clay ball, so much smaller than the bean and smaller than that eyeball, which is like staring at me. Stop staring at me. That little clay ball is more dense than everything, all the liquids and all the objects. Pretty cool, right? So my scientists, to bring this all together, I have for you another lovely drawing, and I thought it'd be kind of cool if we just took these objects and we taped them into the drawing. Okay, these are now stuck together. So this is why I need 2 hands for stuff. Okay, so we're going to start with the ball of clay, and we know that it was the most dense of all, went all the way down to the bottom. Then we had the bean. that was more dense than 4 of the liquids, but then it came to rest on top of the corn syrup because it was not dense enough to sink any further. What else do we have? We have that tin foil that's on top of the water, just like that. So the tin foil was more dense than the oil and the alcohol, but then less dense than everything else. Then we have our Q-tip, right, that came to rest at the bottom of the alcohol layer. Oh, Melody has arrived. Hey, Melody. Okay, this is not where you get food right now. This is my science lab. And last but not least, we have our eyeball. That eyeball is still staring at me. Stop staring at me. Okay, so we have the eyeball, and we know that the eyeball was the least dense of all. So the eyeball lives at the top, staring at us forevermore. So boys and girls, there we have it. Different objects of different densities, different liquids of different densities, and an eyeball on top to boot. So this is one of my favorite experiments, and I hope that you do some experimenting with some different liquids that you have at home, some different objects that you have at home. Please do not just start taking stuff and throwing it into all different liquids. Don't get yourself in trouble. Don't get me in trouble. Get parent supervision, get parent permission, and I do realize that normal people do not have like a bag of eyeballs lying around. So even though this is called floating eyeball, I'm sure that you will not have an eyeball. At least I kind of hope you don't have an eyeball. But at any event, I can't wait to see what you show me. You can even draw pictures and send them to me. And yeah, that's it. This concludes our floating eyeball experiment. I really hope that you liked it, and I will see you next time. Bye.